the class here. Okay. I'm not sure whether you already watched the video class I already posted in your e-learning, but I just want to recall back lah. Recall back what you have learned. Not what you have learned, what the course information. Can you see this one, the slide here? I already shared with you. This is the course information about DE, differential equation. Okay, sorry, before that, my name is Dr. Rahima Mahad, and this one, the second last name here, and that is my office number and my contact number and also my email. If you have anything to contact me, you can just PM me. Okay. Okay, and then okay, this is the CLO. This is our planning for this course, where you can see the important notes here, the remarks here, where your test one is on 20th April, Monday. And then we have your test 2, 8/2. Okay, so you can just look at the remarks here, and these are the public holiday. Okay, and for the quiz, these are the continuous assessment where we have your test 1 and get your test 2. And for the quiz, for my class, we will do through e-learning portal, where the quiz 1 and quiz 2 should be in via online. And for the assignment, I'm not confirmed yet the method for the assignment, the assessment. I will inform you later. And the last one is about the final exam. Okay, the final exam, 40%. This one is 60% for the assessment. Okay, and these are the references that you may refer for this subject. And for our main reference is by using this book, Differential Equation. This one is from the Pernabe UTM. Okay, but maybe you can buy from, I'm not sure, I will confirm with you later, okay, about this book. This book, if you look, you buy and you just go through the inside of the book, there are many examples and also many exercise for you to do this exercise here. It's more details about the subject, the differential equation. Okay, that is for the course information. So today we will go to the first chapter. First chapter is, yeah, sure, this one already mentioned to you about the chapter. There are 5 chapters in your syllabus, where we have the ODE for the first order, ordinary differential equation for the first order, and we have the ODE, ordinary linear equation, differential equation for the second order, and for the higher order, you have the Laplace transformation and the Fourier series. That all the chapters are included in the that book, the differential equations. Okay, so we go to the first chapter. Actually, I already posted to you, share with you the video about this one, the first chapter here, but I'm not sure whether you already watch and learn about that one or not. Have you watched the video? Already posted through VLE, sorry, not VLE, through e-learning last week. the earlier chapter here. Maybe you can just write if there is anything you want to ask, you can just write through the chat column here. I'm not sure whether you have watched or not the video about the DE. I already posted in e-learning. Okay, can you see this one? Can you see this one? The screen here?
Nampak, Doktor?
Yes.
Doktor,
Yes.
saya punya e-learning masih keluar section lama.
Still keluar apa?
Section lama punya e-learning.
Oh, okay. So maybe you can ask, I'm not sure, ask the ICT. I'm not sure lah about you can, is it ICT or the IT unit? I'm not sure UTM what call that one, maybe IT unit or ICT. Maybe you can ask them to change your session. Okay.
Thank you, Doktor.
Yeah, because last week we are starting to changes the session. Some of the students, the new student coming into my session, and the previous student, you may watch the video that I already posted through the e-learning. Okay, it's okay. I will just recall back learn back about this one, the differential equation. Can you see the screen here, what I'm sharing with you? Yes, okay. So this one, okay, so okay, this is our first chapter where the first order differential equation. So today I will give you the what we call the lecture, and tomorrow you will do the I will share with you the tutorial in e-learning, so you can do by your own about the tutorial to test your understanding about this chapter. Okay, this the table of contents where we have the first order ODE and the methods of solution, and we also have the application of the first ODE. Okay, there are how many? 1, 2, 3. There are 3 methods for the methods of the solution for the ODE. Okay, so we go here. What is the basic definition and of the ODE? For the ODE, what is ODE? ODE means that we have one or more dependent variables. This one. Okay. Contain one or more dependent. What is dependent variables? If you look here, this is the example. And that one is respect to one independent variable. So means that in one equation, you have dependent variables and independent variables. Okay. We have 2, dependent and independent. However, for dependent, you can have more than one. And for the independent, you only have one independent variables. That is for the ODE. So what is dependent and independent? This is the example. These are the example here. Why is the dependent? Dependence means that the variables at the denominator, numerator, the upper part here, numerator. And for the denominator, we will call as a independent. This one. This is dependent. This is dependent. Y. And another one is independent. Independent is at the denominator. Okay. Independent for ODE, because ODE one differential equation. So that why you have only one, x only. Okay, with respect to x only. However, for your y, for your dependent, it can be more than one. Okay, that is for the ODE, first order. This is what is it? What is the type? First order ODE. First means one. So that's why your independent must be one only. Okay, x only. X or any variable, but that should be one only. So these are the example here. For the first one, we only have x. This one, we have only x here. And the second example also x, and the third one also x. Okay. For the dependent, it can be more than one. Okay, what is the partial differential equation? That is for the ODE, ordinary differential equation. What is for the partial? Partial involve one or more dependent variables. Okay, similar to the ODE. However, the independent may have more than two, more than one, two or more independent variables. If you look from the previous one, you only have one independent. However, for PDE or partial differential equation, you may have more than two or more independent variables. If you look here, this is the independent variables. You have the value of x and y. That is why we call the independent. However, the upper part here, u, this is the dependence variable. Means that if you want to get the answer of u, differentiate u, you may depends on x and y. Okay, however, x and y is independent, not depends on u. That's why we call u is dependent, and your xy is independent. Okay, so this one is similar to previous ones. This is your independent, because that is the numerator, and the upper part here is dependent. Similar to this one, you have x and t. X and t, that is we call the independent, and u is the dependent. Okay. So from here, you can also determine whether which one is dependent and independent. So from this example, which is dependent and which one is independent? Hopefully you can differentiate between dependent and dependent. So from here, we can see that the dependent is W. W is the dependent, and the independent is X and T. This is a partial PDE, partial differential equation. Similar to the next example here, U is the dependent, and for the independent is X and Y. Okay. Okay, so for the ODE, we can determine the highest derivative. The highest derivative, this is how we want to identify the order of the differential equation, DE. So how we have to know how we have to find the order of ODE is by determine the highest derivative. If you look here, this one is 1. 1 because your x is power of 1. This is power of 1. So the highest derivative is the highest power in the equation there. So from here, the first equation here, the highest derivative is x power of 1. So the order of the ODE is at power of 1. Okay. So for this one is 2 because this one you have the square here. So the highest power is 2. Why is it moving? Okay, and the last one is 3 here because that is the highest. This one is dy over dx. Yeah. And for this one, is it okay? Maybe for this one, this is the exponent of the highest derivative. This one is 1 because the highest power is, this is highest derivative. This is 1. Okay, how about this one? The highest derivative. 1, 2. Is it this one, the y here? Okay, maybe this one you can check later, okay, about how the highest derivative. And you can do the example here as well. The order and the degree here. Okay, next we go to the linear differential equation. Linear means that the highest power of the linear means that the highest power is 1. If you have the what we call the other equation, for example, the quadratic equation, that is not the linear. Linear means that if you draw the graph, you will get the line equation here. Sorry, this one is not straight line. You will get the straight line, the linear equation. Okay, if you draw the quadratic, usually you have the U shape, you have the like this, right? So that is not the linear equation. Okay, so the highest power of the linear equation must be 1. Okay, so we go to this one, we go the description here. The derivative are degree of 1 and each coefficient of the derivative depends only on the independent variables. Okay, so we look here. This is the example here. The coefficient of the derivative only depends on only the independent variables. This is linear because if you look here, this one is 3 and 9 only. You look at the coefficient. That's why this one is power of 1. So that's why this one is linear. Okay, and then for this one, non-linear because the degree here is not 1. If you look here, so this one is power of 4 here. Okay, and then after that, this one is also okay, this one is also non-linear because this one, you have the power of square, the square and the cube. And sine is also not linear. This is also non-linear because if you draw the graph of sine, it will be curved. Okay, curved graph, and similar to this one. This is also non-linear. Okay, so you can identify which one is linear and which one is non-linear. Okay, other non-linear means that other than linear differential equation. Okay, so by knowing the information about the linear and the non-linear, we can solve the initial and boundary condition. This is the initial and boundary condition. So what is initial condition? Initial condition means that will be given on specific point. Okay, specific point. And for the boundary condition will be given on some point. So usually initial conditions usually at the starting point. At the starting point of the equation. Usually we will start from 0. Okay, that is the usually. But however, you can change depends on the question given to you. Okay, that is for the initial boundary condition. So how we want to solve? This is the example question for the initial condition where you have y0 equal to 1 and y prime 0 equal to 2. And the boundary condition, it may include any point. Okay, may include any point. 1y equal to 5 and y2 equal to 2. Okay, this is how we want to solve the initial value problem where you want to solve the d squared y over dx squared plus 2 dy over dx plus y plus sine x, and given to you the initial condition here. This is the initial condition where you have the y0 equal to 0 and y prime 0 equal to 1. At the end of your solution, you need to substitute the initial condition to get the answer. Okay, you can get the answer. Okay, so how you want, this is, means that this is the example question for the IVP, and you may also have the, another example for the BVP, boundary value problems. The same equation, but given to you different condition. The first one is initial condition, and the second is the boundary condition. Okay. So how you want? This is just the example by using the IVP and the BVP. So next we go to how we want to types of the first order ODE. There are 5 types here: separable equation, homogeneous equation, exact equation, linear equation, and Bernoulli equation. So we go to the separable equation. How we want to solve the ODE by separable equation? Okay, separable means that you can separately the equation between two variable. Depends on the variables given to you. How many variables? Usually 2 lah for the separable equation. Okay, how we want to identify? Okay, suppose that fxy equal to dy over dx and ux equal to ux vx. So hence, this become a separable equation. If it can be written as, you can separately. If you look here, for the first equation here, you have the variables, you have only x and y. So means that you can separate between x and with the variables of x and y. So if you look here, this is your x, you separately x and this is y. Okay. So after you do the separation, so what is the next methods or step is you need to integrate both sides of the equation. You need to do the integration. This is the next step. You need to do the integration. Okay, so you need to memorize what is the step. Separable means that first step is you need to separate the equation. between two variables. And then after that, the next step is you need to integrate both sides of the equation. And after that, that is only lah, that one. Okay. So for this one, you can try to do the separation. So from here, dy, this one is the example. Example, how you want to rewrite the following function into separable form. So from here, you can see that you have dy over dx. So you can separately, you move here. And this one, you move to the other side. Sorry, not that. Why you put one side means that your stack y here, you put downside. And your x, you move to the other side. So you will get for E is equal to dy over stack square y equal to 1 over x, 1 over 1 over 1 plus x squared dx. Okay, and then after that, you do the second step, which is you need to do the integration. For this one, you just separately do the separation. Okay. For C, you can dx over dt equal to x minus x squared. Okay, and then you can separately 1 over x minus x squared dx equal to dt. That is for C. Okay, you can try the rest. B, D, E, F. How to do the separable form. Okay. I will give you the notes here, the notes in PDF through my e-learning, so you can check later, okay? I'm not sure in my e-learning I already posted I think I already shared with you the notes in PDF. So you can try later how to separate the form here. Okay. You can try to do the rest here. Okay, and then this is the example. Example, how we want to solve the initial value problem. Okay, given to you this equation, and this is the initial value problem where y0 equal to 1. Okay, so your first step is you need to separate the function. You need to separate the function means that you put your y into one side and your x into one side, the other side. Okay, you need to separate between x and y. So this is the equation here, the question here, where your dy over dx is equal to dy over dx. This one you separately write separately between your x and y. Okay, so I write cos x times with y over 1 plus 2y squared. So by using this, the first step here, okay, you can know how you want to separately. It's more easier for you. Separately between x and y. So after you write in this form, the first form here, and then you put all your y here, you put all your y, you move to the other side. Okay. So you change the upper and the denominator, the numerator and denominator. You will get 1 plus 2y squared over y. How you want to get this one? Actually, you move, you will get a divide, right? So you will get 1 over y over 1 plus 2y squared. Okay, so 1 divided by this one, you can change the numerator and denominator, so you can get this one in this equation here. Okay, so you get 1 plus 2y squared over y. dy is equal to your cos x, you remains this side, cos x. And your dx, you move to the other side. Cos x dx. Okay, after you separate the function, you integrate. Your next step, if we need to do the integration for both sides. So this one, I separately, because y here, the denominator, so I can rewrite in this form. 1 over y plus 2y dy equal to integration of cos x dx. Okay, so integrate of integrate of 1 over y, we get ln y, and you integrate 2y, we get y squared. And for the cos, you may refer to the formula of trigonometry. So integrate cos, you get sine x plus c. This is the equation. So by using the initial value problem here, the initial value here, you can get the value of c. You can get the value of c here. If there is no given to you the condition, so your answer, this is your final answer. However, if given to you the condition, so you need to substitute the value. So the value is x is equal to 0 and y is equal to 1. This is the value. And you need to substitute the value into the final equation, upper part. So your y is equal to 1 and your x is equal to 0. You can get c here. Okay, c. So c is equal to 1. So the final answer is, you substitute back, what is your c? This is the final answer. Okay, is that clear? That is for the example for the IVP. However, some DE may not appear separable initially, but through appropriate substitution, the DE can be separable. Okay, this is the example too. Are you copying the next given, or I can just move to the next slide? Okay, that's one. I just go to the next example. Show that the differential equation dy dx equal to x plus y squared can be reduced to a separable equation by using substitution. Z is equal to x plus y. Then obtain the solution of the original DE. So from here, if you look from the equation here, we can see that this one is not appear to separable initially. It cannot be easily separable. So it needs to use the substitution. So that's why given to you the substitution of z is equal to x plus y. So by using the substitution, it can help to reduce, to separate the equation of dy dx here. So how we want to solve this type of equation, this type of question? Okay. So the first one is, we differentiate both sides of the substitution with respect to x. Okay, given to you the substitution is z is equal to x plus y. So you differentiate with respect to x, both sides. The substitution with respect to x. So you will get dz over dx is equal to, you differentiate 1 plus dy over dx. Okay, so because in the question, if here is dy over dx, so that's why we want to get the dy over dx. So dy over dx is equal to, this one you move, because you want dy dx, right? So this one you move to the other side. So you get dz over dx is minus 1 is equal to dy over dx. Okay, and then after you get, by using the substitution here, you move to the equation here, over dx, dy over dx. This one. You substitute into this equation. You substitute into this equation, where dy dx is equal to dz over dx minus 1. This is actually dy over dx is equal to, this is the equation, dy over dx is equal to x plus y square. X plus y square. So you substitute. So dy dx is dz over dx minus 1. So that is this part. And x plus y is equal to z. So that's why this one is z square. Okay, and then after that, you can do the separable form. You can separately between x and z. So dz over dx is equal to z square plus 1. You write into this one. And then you separately between z and x. So you move this part z to the other side. So you get 1 over z square plus 1. And your x you move to the right hand side. So that's why over, equal to dx. This is the separable form. Okay, after you completely separate between two variables, you can do the integration. Start to do the integration. So you integrate both sides. Integrate 1 over 1 plus z squared. This is, you may refer to the formula, table of the formula. You can get tangent inverse z is equal to x. This one is actually 1. This is actually 1. Okay, 1. So if you integrate any constant, you get the value of variable, because this one is x. So that's why this one you get x here. Okay, x plus c. And you substitute back your z with x plus y. So this one substitute x plus y. So you move your tangent inverse to the other side. So you can get tangent x plus c. Okay, and then actually it's not moving lah. It's just like you times with tangent. You times with tangent x. Because you want to eliminate the tangent inverse here. You want to eliminate the tangent inverse. So that's why this one you times with tangent x. The right hand side also you need to times with the tangent x. So that's why this one we got the tangent. Tangent x plus c. Okay, because you want only your y, so you move your x to the other side. So this is the final answer. And for this question, there are not given to you any boundary, BVP or IVP. So you no need to find this value of C. But if given to you the IVP and BVP, you need to find the value of C, the constant there. Okay, that is how you do the by using the substitution here. Okay, so tomorrow you can try to do this one. Because tomorrow we are not going to have the online class, but please do the question. This one, the past year question from the past year test one. However, I will post to you through the online class e-learning the next chapter. Sorry, not the next chapter, the next subtopic. Okay. You may refer to the e-learning for the next subtopic video. Okay, you may try this one as well, the question from the past year. given to you the IVP, and you need to separately in the separable form, and then after that you do the integration. And after you do the integration, you need to substitute with the IVP here to get the value of constant. The constant, it may be any variables, not only C. You can put A, B, C, and any variable. That one is the constant. And this one is, this one you need to solve the equation here, given to you the IVP. And this is the condition. Okay, you can try. You may refer to the marks given, means that the solution is not too long, only 5 marks. Okay, and in the last example, the last equation is about substitution. Substitution, you may refer to the second example given to you here. Second example about the substitution. Okay, please try, okay? Please try. This one is 6 marks. And given to you the, means that from all the, this one is no given to you the condition, boundary condition. So you just left your answer with the constant. Also this one. Okay. Please try, okay? I already upload the notes PDF in your e-learning. So please try. Okay, and then after that, this is the example of solving. I will just show you how to solve the initial for the question 1 here. Is it? Oh, yeah. So question 1, dy over dx is equal to, this is from the question, x plus y, 1 over y. So you separately between x and y, you put your y into one side and your x into one side. And then after that, this one is improper function. So you need to get the proper function, y divided by y plus 1. So you get 1 minus 1 over y plus 1 here. This one, 1 over. Okay. And then after that, you can start to do the integration. After you simplify the equation, you can get the integration. So integrate 1, you get y. Integrate 1 over 1 plus y plus 1, you get ln y. Okay. Okay, and then x, you get x squared over 2. Okay, this is your final equation. And then after you get the final equation, you use the condition. What you do the substitution. Your x is equal to 2, your y is equal to 0 into this equation to get the value of c. So after you do the substitution, you can get your c. C is equal to -2. So the final answer, you do the substitution with c -2. This is the answer for question 1. Okay, you may try the other equation, the other question here, 2, 3, 4, 5 as well. Okay. Next is the homogeneous. Is there any question you want to ask before we move to the others? Equation? No? Okay, before we end our class later, please ask about your attendance. I forgot about your attendance, okay? Okay, next is the homogeneous equation. How you want to find the homogeneous equation? Okay, suppose that your fxy equal to dy over dx. So fx is homogeneous if you times your lambda here. Lambda means that every real value of lambda, you can get the question back. In the question back lah. You can get the question back. Okay, the equation of the question. Okay, so this is the method of the solution. So however, the first one is determine whether the equation is homogeneous or not. Okay, if homogeneous, you need to use the substitution. Y is equal to Vx and dy. This one you need to memorize, okay? Y is equal to Vx because this is the method how to solve by using the homogeneous. Y equal to Vx and then you differentiate your y. So dy over dx, you will get v plus x dv over dx, the original. And then you separate the variables of x and v and integrate. Actually, the next step, similar to the previous one. The difference is only this one. You need to know the substitution. Y equal to Vx and this one. The next step is similar to the previous. Okay. You need to separate between x and v and you need to integrate both sides and use the initial condition if given to find the constant value, to find the constant value. That is, if you look here, that is what we call the separable equation method. This is what the separable equation method. Okay, the difference is only second step here. You need to do the substitution. Y is equal to Vx and dy over dx is equal to v plus x dv over dx. This one. This is the product rule. How you want to get y is equal to vx and then you use the product rule to get dy over dx. Hopefully, you all can memorize back what is the product rule. Okay, this is you get the equation here by using the product rule, the formula here. Okay, this is the example. Determine whether the DE is homogeneous or not. So, if you want to determine the DE is homogeneous or not, by using this one, the definition here, you times with lambda, you can get the equation back. You can get the equation back. Okay, so we look here, dy over dx is equal to x squared plus y squared over x minus y x plus y. Okay, so this one, you times with lambda. You times with lambda. Lambda is any real number. Actually, lambda is any real number. So that's why we put lambda. Lambda. So if you times with lambda, lambda x, lambda y, so all the x and y here, you substitute with lambda x and lambda y. This one is lambda x, lambda y. All the value you substitute with lambda x and lambda y. Okay, and then after that, because there are similar lambda here, you can do the factorization. You factorize, you take out the lambda here. So that's why you get lambda square. So the balance is, the rest is x squared plus y squared. Similar to the denominator here, you can do the factorization. You can get the lambda. Because this one is lambda, you take out, you do the factorization, you will get lambda x minus y. And the second part also, lambda x plus y. So lambda times lambda, you get lambda square. X minus y. And this one, x plus y. Okay, so that's why you get this one. Numerator here. Okay, lambda square, x minus y, x plus y. So you can cancel the upper lambda and the lower lambda. You can get back the equation here. If you look here, this one is similar to the equation here. So your f lambda x, lambda y is equal to fxy. So from here, you can make a conclusion that that is the homogeneous. Okay. For B, B similar step as well. Given to you the function, the equation here, Okay, so you need to times with the lambda. So lambda x and lambda y. So you write lambda x, lambda y, lambda x plus you times all the lambda in the equation. Okay, so for the first term you can cancel the value because this one you have the lambda and lambda. You can cancel the value. However, for the second term here, this one, the second term, you can take out the lambda, but you cannot eliminate the lambda here. So in this equation still have the lambda. So means that your f lambda x f lambda y is not equal to the f x f y here. Okay, so from here we can make a conclusion that this DE is not homogeneous. This DE is not homogeneous. Okay, that is how we want to check or how we want to determine whether that equation is homogeneous or not. Is that clear? Okay, this example is you want to check if that is homogeneous, so you may proceed with the solution here, method of solution. If that is not homogeneous, you cannot use this method of solution. Okay, so we check here example to solve the homogeneous equation. Okay, so from this example, it's already stated to you that this equation is, this question is homogeneous. So means that you no need to check whether the homogeneity of the equation. Okay, so we already know that this is a homogeneous equation. So you just go to the next step. After the homogeneous, you do the substitution. Okay. So we do the substitution. This is from the notes given to you. Your y is equal to Vx and you can get your dy over dx. Okay. And then after that, y square plus xy dx is equal to, you move this one to the other side. So you can get this form, into this form. Okay. And then you get your dy over dx, dy. This one you move the x to the other side. So you can get y square plus xy over x square. You can get this form. Why you want to get dy dx? Because you want to substitute the form here, the substitution here. You want to substitute dy over dx into this part. So you substitute with v plus x dv over dx is equal to, so your y, you substitute with the substitution in the homogeneous solution. So your y is equal to vx. So you will get v squared x squared plus x. You substitute your y. Anything y, you need to substitute with vx over x squared. Okay, and then after that, from this one, you can do the eliminate the x. You do the factorize your x, so you get x squared v squared plus v over x squared. So this one you can cancel the value. So the rest is v squared plus v. Okay. And from this part, you can cancel the value of v here. Because if you move to the other side, you get v minus v. So v minus v is equal to 0. Okay, so that's why you can cancel. So the balance is you have this one from this one. X dv over dx is equal to v squared. Okay, that is the equation. After that, you do the separable form into the separable form where you need to separate between V and X. Okay. So your V squared, you move to the other side here. Your V, you move to the here. And your X, you move to the right-hand side. Okay. So you get into this form. And you will start to do the integration. Integration, this one you bring to the upper part, upside. So you get V power of -2 and you do the integration. Okay. So you get integration of 1 over x is equal to ln x plus c. This one you bring back into the negative, you bring to the denominator. You get -1 over v equal to 1 over v equal to ln x plus c. Okay, and then you substitute back your v with y over x. Where you get v equal to y over x? From the question here, from the notes here. Y is equal to vx. You already know that. You already know that your y is equal to vx. Y is equal to vx. Okay, so we want to substitute your v. So you need this one, you move to the other side. So you get y over x. Okay. You substitute your v with y over x. Because we don't want any v anymore. So this one you substitute into this part. Sorry. You substitute into this part. Nice. Okay, so 1 over y over x is equal to x over y. So integrate, you get already integrate, right? So log x, so you want your y, so y is equal to 1 over x ln c plus, ln x plus c. This is your final answer. Okay, but for this example, not given to you the IVP or BVP, so you no need to find the value of C here. Okay, note that the non-homogeneous can be reduced to homogeneous equation by using the right substitution. Okay, because this one is homogeneous, so this one you can just solve by the homogeneous. This note is for the next one, the next slide. This for the next example here. Non-homogeneous can be reduced to a homogeneous equation by using the right substitution. Okay, have you done copying the notes given? Or maybe you can refer to the video later. Okay, next. This one. Find the solution for this non-homogeneous equation, equation 1, by using the following substitution. Because this is non-homogeneous, it's already stated to you that this equation is non-homogeneous. So you need to solve by using the following substitution. As mentioned in the notes given here, the non-homogeneous can be reduced to homogeneous equation by using the right substitution. So this is what we are going to do for this example, where this is non-homogeneous, but we want to do the substitution. Okay, to do the substitution to get the homogeneous. This is the substitution where your x is equal to x plus 3, capital X plus 3, and your y is equal to capital Y plus 2. Okay, given the substitution, by using, you need to use the substitution, okay? Differentiate the given substitution with respect to the variables. So if you look from the question here, this one is you substitute with respect to x. So that's why your substitution, the substitution you need to respect to x as well. Okay. This one is x. So with respect to the respective variables, sorry, the respective variables means that depends on the substitution. If the one is respect to x, this one is respect to capital X. And this one respect to capital Y, this one is also respect to the capital Y. Okay. So dx over d capital X equal to, this one you differentiate. X you will get 1. And constant is 0 lah. And y you get 1. And this one is 0. So you bring your dx to the other side. So you get dx equal to dx. And dy is equal to d capital Y. Okay, this is, and then after that, after you get your dx and dy, d capital X and d capital Y, you need to substitute back into the question here. Okay. And you substitute all the substitution because we want to do the substitution. That is what we call substitution. Because we want to substitute all the following substitution here into the equation here. Okay. You want to substitute the value of x, x plus 3 into the question. That's why we call substitution, substitute. Okay, so we get dy over dx because from this one. And you substitute what is your y, what is your x, and what is your y again. And you simplify. This one you can cancel, so that's why you get y. Okay, and then this one also you can simplify. 3 plus 2, 5. 5 minus 5 is 0. So you can cancel all the value here. So you get y over capital Y over x plus y. Okay, and then okay, after you can after you do the substitution and you separately proceed with the normal step of homogeneous solution, where the homogeneous solution means that you need to use the y is equal to vx and what is dy over dx. Okay, so from here, the last step, you know that this is dy over dx. So dy dx, this is dy dx. You substitute with this one. Dy dx, v plus x dv dx. This is what you got here. V. Okay. And then vx, you substitute your y. Y is what? Y over x plus y. So this is your y. This is your y. This is your y as well. Okay. And you move your v to the other side because you want to get the dv over dx only. So you will get v, and you can cancel the value of x. You do the factorization, you can cancel, so we get v over 1 plus v minus v. Okay. And then you can combine this one, simplify. You can get this step. This one means that you need to times with 1 plus v. Times with 1 plus v. And also this one, you times with 1 plus v. This one, 1 plus v. And this one as well, 1 plus v. Okay, so you get v minus v, you can get this term. And then after that, you do the simplify. V minus v minus v. This one, you need to expand first and then you simplify. So you will get negative v squared over 1 plus v. Okay. Okay, and then next step is this is this is what the final one, x dv over dx is equal to negative v squared over 1 plus v. So you do the separation. Actually, your equation is like this. X dv over dx equal to negative v squared over 1 plus v. So you need to separate it between v and x. Okay. So you move your x to the other side, to the right hand side, x. So this one you will get 1 over negative x. Your negative you remain to the right hand side, okay? And the rest here, your v, you move to the left hand side. So that's why you will get 1 plus v over v squared. Okay, your negative you remain to the right hand side here. So after you separate between the variables x and v, you can do the integration. Integration here. This one you can simplify. You can simplify to easier for you to do the integration. So you separate between 1 over v squared plus v over v squared. So you can get this one. Okay. And this one is, this is nothing happen now because you only have one segment. Okay, so you do the integration, you will get v negative 1 over negative 1 plus ln v minus negative ln x over c. Okay. And you simplify, you move, you just rearrange the terms. You write ln v minus 1 over v equal to c minus ln x here. You get instead this one, v minus x. X, you put your ln x into one side because you want to simplify the ln. Okay, so your ln you bring to the left hand side. So we will have ln v plus ln x is equal to c plus 1 over v. By using the ln properties, where if there is plus here means that you can simplify ln vx. This one is from the properties, okay? You can check the properties of ln and exponent. If plus, we get times the product. So ln vx is equal to c plus 1 over v. Okay. And then after that, okay, another properties is if you want to eliminate the ln here, you can use the exponent. So means that you can exponent all the equation here because we want to eliminate the ln here. So you can write exponent ln vx equal to exponent c plus 1 over v. Okay, so this one you can eliminate. So you can get your vx. Vx is equal to, that is what I get from here. That's why I get from here. No, this one. That's why I get the equation here. Vx is equal to exponent c 1 over v. So exponent c is actually any constant. So we let means that exponent c is any constant. So exponent c you can let is equal to a. For this example, okay? For this example, you let your exponent c is equal to a. A is any variables. You can let any variables b, d, e, and so on. So, but for this one, I put a. So you can, actually you get exponent c times with exponent 1 over V. So exponent C is equal to A and exponent 1 over V. Okay, and then after that, you substitute back your V with Y over X. And this one you can cancel the value here. Cancel. You can get your Y is equal to exponent Y is equal to A exponent X over Y. Okay. And then you substitute your capital Y, capital X with the from the equation here. Capital X and capital Y. Okay, so your X is equal to, capital X is equal to X minus 3 from this part, okay? From this part. Capital X is equal to X minus 3 and capital Y is equal to Y minus 2. So, we can get this one, X minus 3, Y minus 2. Okay, and then you want to find your Y, you move your 2 to the other side. So, this is your final answer. Okay, so you can try the past year question here as well. You can try the past year question. Please. Okay. Okay, so we already learned about we already learned about the homogeneous, and then how you want to solve by using the separable form. This one you can try, okay? The past year from test 1. Okay. Show that this is homogeneous. So how you want to check the homogeneous? You substitute by lambda x and lambda y. Okay, if after you do the substitution, you can get the similar, like in the equation here. If similar, so you can conclude that that is homogeneous. If not, means that that equation is not homogeneous. Similar to the second equation here, the second question here, you need to check first whether it is homogeneous or not. If it is homogeneous, so you can find the solution. Okay. This one is also, but this one we have the initial value problems, means that you need to find the value of C to solve the question. There is another method, but what is it? Okay, I need to move down here. This one is moving the words here.
Boleh tak?
Okay. The words moving here. Can you have any question want to ask? Do you want to proceed with this one, the exact equation? So from this one, we already learned about the first order or the ODE. and then separable form, separable solution, and then about the homogeneous, how we want to check the homogeneous. And then for the homogeneous, there are two types. The first one is you need to check whether that one is homogeneous or not, and then after that you solve by the homogeneous method. And if that is not homogeneous, means that you need to do the substitution. Okay, to do the substitution, and then after you get the substitution, then you start to do the separable. Okay. Do you need a break or maybe take 5, or you want to proceed with the exact equation? Okay. So maybe we can just I just show you the exact equation, and if you are not familiar or you need to recall back, you can just watch, because this video I already I already record the video and I will post it in the e-learning later. Okay, you can rewatch again and again if there is any problems with the notes given to you. Next, we go to the exact equation, where how we want to identify that is exact equation or not. Suppose that fxy is equal to negative mxy over nxy. Okay, so therefore the first order DE is given by this. So you separately, you separate this one, you cross the product here, cross product. So your m x y dx plus n x y dy. So this is, you let this is du delta u over delta x, and this is for delta u over delta y. This one is equal to 0. And the condition for exact equation is delta m over delta y is equal to delta n over delta x. If equal, if you do the you get equal, means that that is for the exact equation. Okay, there are two methods of solution. Methods of solution. This is how you to. The first one is you test the exactness. If equal, means that that is the exact. Okay, so if the D is exact, means that m is equal to delta u over delta x, and n is equal to delta u over delta y. Okay, means that equal. So, and then after that, you need to do the integration. Integrate 1 with respect to x. We get this one. You have your phi y. And the second one is you integrate from 1, you integrate, differentiate to determine the value, because if you look here, you have the phi y here. So how you want to get the phi y? You need to differentiate. To determine the phi y, differentiate 3 here with respect to y. Differentiate phi with respect to 3 with respect to y. So you can get the phi here. Integrate phi to get the phi y. Replace phi y into 3, so you can get the phi, and write down the solution. Maybe it's more easier to you if I give you the example lah. If I just give you the step here, is might be confused. Okay, there are two methods. The second method is you write DE in the form of M, similar to the previous one, and you need to check the exactness as well. Okay, and then if the D is exact, so M is equal to, this one is similar to the previous step. So integrate 1 with respect to x, you will get phi 1, and integrate 2 with respect to y, so you get phi 2. This is the difference. This is starting to get the difference between the method 1 and method 2. And you need to compare 3 and 4 with respect to the value of V1 and V2. Okay, replace V1 into equation 3 and or V2 into equation 4. Okay, if given to you the initial condition, you can substitute. So you can write down the full answer of the solution. Okay, so we will get, go to the example here. Okay, so 2xy plus 3 dx plus x squared minus 1 dy equal to 0. Okay, this is by using method 1. So method 1, you check, the first one is you check the exactness. Where is your m? This is your m. And this is your n. Okay. If you look here, your m is dx. M is for dx. And your n is for dy. Okay. So, this one, m, dx, and dy. So, your m is equal to 2xy plus 3. So, delta m over delta y, you differentiate respect to y. So, you get 2x. And your delta n over delta x, you get 2x. So, from here, we can see that delta m and delta y is equal to x and 2x. So, this is exact. Okay. So, means that this is exact solution in the equation. So, you can get the delta u over delta x. Delta u over delta x is, let delta u, we do, this is method 1, right? Method 1. So, method 1, where is the, you let your delta u, this is delta u over delta x, and this is delta u over delta y. Okay. So, delta u over delta x is equal to, you let 2xy plus 3, and delta u over delta y is equal to x squared minus 1. This is your equation 1 and equation 2. And you integrate 1 with respect to x. Okay, 1 with respect to x. So you will get x squared y plus 3x plus phi. I get phi here. Okay. And then you go to the second one. Delta u over delta y. Delta u over delta y is x squared. Sorry, you need to differentiate. This is your u, right? This is your u. You need to differentiate with respect to y. So delta u over delta y, you differentiate this one. So this one we get x squared plus 3x is not u, so that's why this one is 0. And your phi y with respect to, you get phi prime y. And then you compare with 2. You compare with 2 because this one is delta u delta y. So that's why you need to compare with equation 2. After comparing, we can see that your phi prime y is equal to -1. This is -1. Okay, so phi prime y is equal to -1. And how we have to get the phi y? You need to integrate. Because this one is prime, so how we have to get the phi y? You do the integration of phi prime y dy. So integrate -1, you will get -y. -y here. Okay, so we write down uxy is equal to a. What is your u? U is this one, x squared y plus 3x plus phi y is what? Phi y is y, -y. So that's why we get this one. X squared y plus 3y minus y is equal to a. And you use what we call, you factorize x, you get your y. Y is equal to a minus 3x over x squared minus 1. Okay. If given to you the the condition, the IVP or BVP, you can find the value of a here. But for this question, there is not given to you any BVP and IVP, so no need to find the value of A. So you just let your answer with the constant here. Okay, that is for this one, for the exact solution for method 1. So we go to the using. Is there any problem with this one? No. Okay, we go to the next one. Example 1 by using the method 2. Okay, method 2, delta U, we already know that your delta U over delta X is equal to 2xy plus 3, and delta U over delta Y is equal to x squared minus 1. So we integrate your U with respect to X. Okay, so we get 2x squared. Sorry, you can cancel the value of 2. Actually, we can get 2x squared y over 2. So this one you can cancel lah. So that's why your answer is x squared y and plus 3x plus 3y. Okay, 3y. So, and then after that, we integrate b with respect to y. So this one with respect to y, so we get x squared y minus y plus 3x. This is equation 1, and that is the second one is the equation 2. And you compare the value. This is by using method 2, okay? You compare the value 1 and 2 by comparing the value. So from here, we can see that your y is equal to negative y. And this one, 3x is equal to 3x by comparing the value. So we can see that your uxy is equal to, you substitute the value of 3x and 3y. 3x is equal to, this one is 3, 3y. 3y is equal to negative y, and uxy, another one is, where is another one? Okay, you substitute the value uxy. Oh, because we only have the y, 3y. 3y. Where is the final answer for this one? Wait, I want to check first. Uxy, x squared y plus 3x plus 3y. Okay, similar. So your final answer, uxy is equal to x squared y plus 3x minus y. So this is the final answer. Okay, you can use any method, method 1 or method 2 to get the answer. Okay, sum of non-exact solution, exact equation can be turned into exact equation by multiplying it with an integration factor. This one, the integration factor. Okay, we will finish this one, the last example here. Some non-exact equation can be turned into exact equation by multiplying with integrating factor. What is the integrating factor? This is the example. Show that xy plus y squared y plus y dx, this is the equation, equal to 0 is not exact. Okay, so how to show that that is not exact or not, that is exact or not? By you check whether your delta m over delta y and delta n over delta x is equal or not. If that is not equal, means that that is not exact. Okay, after you show that that is not exact, then the second equation, the second step is you multiply both sides with the integrating factor. This is the integrating factor, mu to solve the equation. Because this equation is not exact, so you need to multiply with the integrating factor. Integrating factor will be given to you. that is coming from this note given. Means that we want to change from the non-exact equation, we want to change to the exact equation. And then after you get the exact equation, then you can solve by using the exact equation. So how we want to change from non-exact to exact? By the integrating factor. This is the example. So you check first whether this is exact or not. So you need to find your delta m over delta y. So delta m over delta y, you differentiate with respect to y. So this one you get x plus 2y plus 1. And this one is you differentiate with respect to x. This one you get 1. So if you look here, delta m is not equal to delta n. So this is not exact. And your next step is you need to multiply with mu. Mu, so all the equation here, from the equation here, you need to multiply with exponent x. Both multiply with exponent x. So this is exponent x. This is also exponent x. Okay, and then after that, your m, so you can get your new m. M is mu exponent x, the function there, and your n is also exponent x, the function here. And you need to differentiate with respect to y. You differentiate with respect to y. So you will get exponent x. This one you differentiate. You get x. You get 2y. This one you get 1. Okay. And for this one, similar to this one, you differentiate delta n over delta x. This one, this is your u. This is your v. Using the product rule. This example using the product rule. So you will get x plus y. So for the product rule, you will get u v prime plus, this one you need to recall back, u v prime plus vu prime. You need to recall back. So you can get this one. Okay. U v prime and then u v prime and vu prime. You differentiate exponent x, you will still get the exponent x. Okay. You get this one. And if you rearrange the what we call the terms here, you can get similar to the first one here. So from here, we can see that delta m over delta y is equal to delta n over delta x. So means that this is exact. We can show that that is exact. Now after you show that that is exact, then you can do the next step. Okay, so from here we can see that you need to, for the exact terms, after that, this one is your delta u over delta x, and this is delta u over delta y. Okay, so if you compare here, we can see that delta u over delta y is more easier to do the integration. So we let your u, you can choose anyone, whether you want to choose this one, the left hand side, or the right hand side. But we choose the second, du d1, because why? Because it is more easier to do the integration. Okay, maybe you can try du dx as one, du delta u over delta x. Okay, so we get integrate exponent x plus 2y dy. And you do the integration, you can get 3x. Exponent x plus xy, because this one you integrate with respect to y, so that's why there is another additional of y here. Y squared. Okay, and after you get your you do the delta u over delta x. Okay, to get the phi prime x. So this one, you respect to x, right? You differentiate with respect to x. So this one, your x you can eliminate. So you can get exponent x, y plus. This one is by using the product rule as well, okay? You use the product rule. This is your u, this is your v. Use the product rule to find the differentiation here. Okay, so let's say your u is equal to exponent x. So your u prime is equal to still exponent x. And your v is equal to xy plus y squared. So your v prime, but this one is respect to, you differentiate with respect to x, right? To x. So you will get y, this one x. So this one is actually delta v over delta x lah. Delta v over delta x. Right, v prime. Okay. This one is respect to x. Okay. So you get your y. So you can use into the formula u v prime plus v u prime. So you get your u is exponent x. Your v prime is delta v over delta y lah. So that's why you get y here. Plus your v. V is x y plus y squared. And your u prime is exponent x. So that's why you can get this one. Similar to what I got in my calculation here. So exponent x, y, x plus xy plus y squared exponent x plus phi prime. This one you need to differentiate phi prime x. Okay. And then you factorize. Factorize. So you get exponent x, y plus xy plus y squared plus phi. And you compare your delta u over delta x with, where is delta u over, this one. You compare with the upper part here. You already get your du over dx. So you compare this one, what you get from this one, phi prime, with the upper part here, delta u over delta x. Why you want to compare? Because you want to get the phi prime x. Phi prime x. So by comparing from this one, we can see that all is similar. This one all is similar. So we can see, you can conclude that we phi prime x is equal to 0. So you integrate, you do the integration, 0, we get constant. Constant means that any number lah, any number. And this is your final answer, plus a. So the final answer, u xy is equal to a. So this is what your final answer. And this one you move to the other side. So exponent x, xy, this one you just rearrange the terms here, xy plus y squared. This one's a minus k is equal to constant, because we just want to simplify all the constant into one terms. So a minus k is constant actually. So we simplify with c. So that's why that is c. Okay. So you can try the to do the past year question, test 1 here. From the PDF I already given to you. Okay. For the linear equation, we will continue by next week, okay? By next week, face-to-face class. So we already cover about what we already covered for today. I just want to recall back lah. We already covered about the separable equation, homogeneous equation, and the exact differential equation. So there are lots of exercise you can try to in the PDF here. I already shared to you by in your e-learnings, so you can check. Okay. So next week we go to the linear first order differential equation and the Bernoulli equation. And before that, I want to take your attendance for today. Wait, I think I need to go to my portal. You are in which section? I already forgot. Wait, I want to check first.
26.
Huh?
26.
Sorry? Maybe you can just write in the chat form. Section 26. Okay, thank you. Okay, you can scan for your attendance for today. Okay, have you done? Scan the attendance. Okay, so for this video, this class video I will post it in VLE. Actually, I just share with you the link, and I will post it through YouTube, and you can just click the link and go to the YouTube. Okay. Have you done finish to scan? All right. Okay. Okay, I think that's all for today. We will continue the class session by face-to-face, right? Face-to-face next week, okay? Okay, I think that's all today. So see you next week. Okay. Wait. Okay. All right. Okay, thank you. Bye-bye.
Thank you,
Assalamualaikum.
Doctor.
Thank you,
Okay,
Doctor.
thank you. Bye.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Doctor.